Now, alright, this is the 12 by 12 example of how to decode a data matrix. Here we have a data matrix right here, and the code is simply 555-1234, as if you were to have like a phone number or something. So anyhow, this is the code, and this is the code with the data area in light gray. So now the first thing we gotta do when decoding this guy is we actually got to go and define where the data words are. Now, actually the second data word, but the first one that we show off is that the one that's always in this upper left-hand corner. So there we are. So that is our second data word. Now, the first data word is going to be down here, and the third data word is going to be up here. But the easiest method to do this is simply just to fill out the rest of these complete data words. So do this, do this, do this, and do this, and do this. That's good. Then we can just keep filling this out. And this is a lot easier than trying to color all these in, I found out. So some of that, some of that, some of that, a little more of this. I know this is tedious and uninteresting, but you know what you're going to do. If you want to solve a data matrix by hand, this is what you got to do. Anyhow, let's see. A couple more here to do, not many more. And oops, darn it, Excel. There we are. That, and that. Okay, so there's our completed all the data words that are the standard kind of L bracket, if you will. So now the next thing to do is we got to fill out the rest of these odd wraparound types. So the first one I always like to do is which would be the third data word, is this guy right here. Now, if there was one here, it would look like this, and like up here and down and over and across. But since of course that's outside the data matrix, going to undo that, and he is actually wrapped around down here. The idea is that we're looking for the wrapped around piece that fits what's missing from up here. Alright, so that guy's done. And so now we have this guy. So now we're missing the top two that are up here. Well, where would that guy be? Well, he'd be right here. He's already kind of pre-drawn out, and it's these two right down there. Okay, so that's cool. So next portion is to do this guy, which is a 6x6 that's missing its right two boxes. Where would that go? That would go right here, as if there were a data word right there branched off the side of this guy. Let's see if I can't draw it real quick. It'd kind of look like this. It'd be this area right in here. So anyways, and then finally this guy here, you can already pretty much guess it. He matches with this guy over here. And what about this little 4x4 chunk down here? Well, actually that guy is completely unused in a 12 in a 12 by 12. So that's cool. So now the next thing we're going to want to do is we're going to want to define which one of these is which. And I remember me saying that this one is the second data word. And this guy is the first, and this guy is the third. And that's always pretty much standard for every size data matrix that you're doing. From there, it actually comes around, starts here, goes up in a diagonal pattern, wraps back around to hit this guy, continues to wrap around, up until I think in this case it goes like there. Not entirely sure about this one, but at the same time it doesn't really matter. Why doesn't it matter? Well, I'll get to that. Let's see, that one's 11, that one's 12. Okay, so there's my basic defined regions. And the 12 by 12 data matrix only has 5 chunks that are used for data. 6, 7, 8, 9, 10, 11, 12 are all used for error correction. And this last guy down here, like I said, is completely unused. So, let's see here. Oh yeah, I forgot to do this. 3 wraps around with 3 over here. 4 wraps with 4 over here. 1 wraps with this guy over here, and this is 7, but it's unused, so I truly don't care. So anyways, this is the byte order, if you will. So now I want to define which of these bits are which, and in the standard L bracket function, like 2, 5, or 6 are, it goes pretty simplistically as this. Let me draw this out real quick. Okay. And then take this guy, bump him down to a font size of 7 because it's too big. Now the bit pattern goes like this. The most significant, or sorry, the least significant bit, 1 starts there, 2 is there, 4 is there because we're adding these all together. 8, 16, 32, 64, 128. So the idea is if we were to take, let's say 5 here, 5 has really its whole right side highlighted. So let's just do the same thing for this guy. Highlight that, and highlight that. So the idea here is that 128 plus 32 plus 4 is the data that we're looking for. Now, I'm not going to try to do math because I suck at math. But let's continue down here. Now, I can see I've done all these steps ahead of time. And here we go. I'll start here because I don't want to get ahead of myself. But here I've already filled out all the data patterns. Now, I got to just re-stress the point of how these things wrap around. 2 here is a complete L bracket, and so therefore it is numbered as you would assume it to be. Chunk number 1 here is actually wrapped around from over here. So these 2 areas here and here, there, are wrapped around with each other. So 128 and 64 as it would be over here. Then 32 and 16 as it would be over here. But 8, since 8 would be here, wraps around to there. And then 4, 2, and the one that would be here wraps around to there. I think you get the picture by now how this wraparound piece works. So, anyhow, I've taken all these and I've labeled them appropriately, and I put little X's in the unused portion. It's just unused. That's all there is to it. And so, now let's break this down chunk by chunk and explain this for you. Now, chunk number 1, I've already done the math and all that good stuff, has 128, 32, 16, 8, and 1 already highlighted. So 128 plus 32 plus 16 plus 8 plus 1 equals 185. Now, the DataMatrix has usually 2, I guess you can have, well, for data, it's like if the number is above 130, then it's a pair of numbers. If it's below 129, it is an ASCII value plus 1. And so I'll get to that ASCII thing in a second here. But right now we have a number that's over 130. So what we do is we simply subtract 130, and 185 minus 130 is 55. And that is our first 2 numbers, 5 and 5. Well, that's pretty cool, huh? Yeah, we've already found our first 2 numbers. Now the second chunk, which is the upper left-hand corner here, has 32, 16, 4, and 2 in it. That totals up to 54. And now it's a value that is less than 129, so therefore we know it's an ASCII value. And so we subtract 1 because all these ASCII values are actually the value plus 1. So what we want to do is we want to subtract 1, which gives us 53. And if we go over here to our ASCII chart, 53 equals an ASCII 5. So therefore that is our next character. It is the, trying to make this look better, there we are, it is our third 5. Now the third chunk, now if you can remember what the original value of this barcode was 555-1234. So coming back over here to the third chunk, this guy is wrapped around, so we have 128, 64, 32, 16, 8, and then it wraps around up here 4, 2, and 1. So we have 32, 8, and 4 and 2 in total, so we add all those together, which gives us 46, which is less than 129. So we know it's an ASCII value, so we subtract 1, which gives us 45. Coming to our ASCII chart over here, 45 equals the dash. So therefore, our next character is the dash. Sweet. So we got our first 4 characters right there. Chunk 4 starts here. Remember how it went 1, 2, 3, and then we came back around to hit 4. So here's our 4 value, and this guy has its top 2 wrapped around to the bottom down here. So 128, 8, 4, and 2. All those combined is 142. It's above 130. So we subtract 130, and 142 minus 130 is 12, which is our next 2 characters, 1 and 2. Huh. This is pretty cool, huh? We're solving. And finally, chunk 5. Pretty easy because it's all right there. It doesn't wrap around at all. 128, 32, and 4, as we did at the beginning, all that total equals 164, which is over 130. So we minus 130, giving us 34, which is our last 2 characters, 3 and 4. So cool. So cool. And so now the rest of these don't truly matter. They're all error correction or the wrapped around values or the unused section. So there you go. That is how to solve a 12 by 12 data matrix by hand. Have fun with that.